Standard Model, narrated by Down Quark'who. Welcome to our world. These are atoms. And here is our village. The nucleus, with green and red homes. The red ones are called protons and the green ones are called neutrons. We live in the country of helium, which has lots of helium atoms. This means that there are always 2 red houses in each of our villages. My home is a proton, and this is my family. I'm called Down Quark. Hello. This is my mum, and this is my dad. They are both called Up Quark. But we are not the only ones who live in our village. There is another family that are just like us in the other red house, the other proton. But in the greenhouse live different families. This is my cousin's family. They live in a greenhouse called a neutron. This is my auntie and uncle. They are both called Down Quark, like me. And this is my cousin, who is called Up Quark. Hello, Up. But you've not met the whole family yet. Me, my cousin and our parents are all quarks, because we live inside the village in the middle of the atom, which is called the nucleus. But let me introduce you to my grandparents. They don't live in our village, but they do live in our atom. Can you see them? They are both called electron, but they aren't quarks like me. They are leptons. This is my grandma, electron lepton, and my grandpa, electron lepton. Between us 8 particles we make everything you see around you. Watermelons, pencils, yo-yos, even you. We are all fundamental particles, meaning we are not made up of smaller parts like protons, nuclei, atoms and objects are. There are other fundamental particles like us too. First, let's meet the rest of the quarks. You've met my cousin Up Quark and me, Down Quark. These are our friends Charm Quark and Strange Quark. And this is Top Quark and Bottom Quark. Me and Up are the lightest quarks. Top is the heaviest. Now let's meet the leptons. This is Grandma Electron Lepton, and here are her brothers, Muon Lepton and Tau Lepton. They are all charged leptons. For each charged lepton, there is an uncharged baby neutrino. So there are 6 leptons altogether. 3 charged leptons, electron, muon, and tau, and 3 neutrinos. Muon and tau have a lot more mass than electron. The neutrinos have very, very little mass. They are also very difficult to find. There are lots and lots and lots of neutrinos in the universe. But they don't interact with other particles. In fact, most of them pass straight through the Earth without interacting with anything. Let's see who you've met so far. The quarks, Up, Down, Charm, Strange, Top and Bottom, and the leptons. The charged leptons, electron, muon and tau, and the 3 uncharged neutrinos. one for each charged lepton. Together we make up all matter that can exist in the universe. But we haven't finished yet, because each of those matter particles has an anti-twin. There are antiquarks and antileptons. Each time a matter particle is created, so is an antimatter particle. They are exactly the same except are oppositely charged. First, the antiquarks. Anti-up, anti-down, anti-charm, anti-strange, anti-top and anti-bottom. As you can see, the antimatter particles look the same as us matter particles, but so we know which is which, we have slightly different signs. They all have a bar on top. For example, my sign is D for down quark, but anti-down sign is D bar, to show we are different. This is anti-electron, but she has a special name, positron. And here are anti-muon and anti-tau. There are 3 anti-neutrinos. Remember, antiparticles have opposite charges to matter particles, so the 3 charged leptons have opposite charges to their antiparticles. But something strange happens when we meet our antiparticles. Watch! This is up and anti-up. Let's see what happens when they meet. They annihilate each other. This means they turn into pure energy. And then, a top quark and an anti-top quark form from the energy. That's not all though. Finally, let me introduce you to the force carriers. First up, the great graviton. This carries gravity. Gravity acts on all particles. Next is a group. Welcome the dazzling W's and zippity Z. They carry the weak interaction. The 2W force carriers are charged, but the Z is neutral. The weak force acts on all quarks and leptons. It allows bigger quarks and leptons to turn into smaller ones. This is called decay. Next, the fantastic photon. This carries the electromagnetic interaction. Photons do not have any mass. They are just packets of energy, and they travel at the speed of light. The electromagnetic interaction acts on quarks, the charged leptons, and the W force carriers. Finally, we have the groovy gluon. Gluons carry the strong interaction. This sticks quarks together. The strong interaction acts on quarks, as well as gluons themselves. The strong interaction holds quarks together in protons and neutrons, and holds the protons and neutrons together in the nucleus. So here are all the force carriers. The great graviton, dazzling W's and zippity Z, fantastic photon, and groovy, gloopy, gluon. So now you've met everyone. The quarks, leptons, antiquarks, antileptons, and force carriers. I hope you enjoyed meeting all the characters in the standard model and having a look at the world of the tiny. Bye bye! end. Goodbye, I hope you enjoyed it.